Next, we're going to look at a linear function that's written in slope-intercept form. And the function g of m models the number of gallons of gas remaining in a vehicle's tank as a function of the number of miles driven. And there's a couple ways we have already identified that we know that this is a function. So it's telling us a function of the number. And so if we recall that the thing right after the words a function of means that we have the input. We also know the input is right inside the parentheses. So, and then for the output always comes before the words a function of, and this is the number of gallons of gas remaining. And that is also outside of the parentheses. Okay, and we also saw it when they first started writing the words here. Okay, so what is our rate of change? Well, keep in mind, remember slope-intercept form is the constant rate of change times the variable. So we know that the constant rate of change is the negative 0.04, because this is the part that is in front of the input variable. And so we have negative 0.04. Change in output is the number of gallons of gas remaining. So this is going to be gallons per, and the output is miles. So negative 0.04 gallons each mile. So now we want to write that in terms of what this actually means. So each mile driven, so that's the input part. The output part is the number of gallons of gas decreases, because it's negative, by 0.04. Or you can say the number of gallons left in your tank is decreasing by, or it goes down by. Left in the tank. All right, so what's the vertical intercept? Well, we know that the vertical intercept is always 0, comma something, and since it's written in slope-intercept form, we know that the something in this case is the 17. It's the part that it's the constant part. And what is that meaning? Well, at 0 miles driven, 17 gallons of gas remain in the tank. Okay, so next we want to evaluate g of 218 and state its meaning, and then we also want to solve. So essentially what it's asking is to plug in 218 into the function, and so g of 218 is equal to negative 0.04 times 218. So that's our input value, plus 17. And when we do this calculation, we end up with an output value of 8.28. So we're going to write another statement just like we did in part B. So after 218 miles are driven, (8.28) gallons of gas remain. All right, so now this time we need to solve. And remember, solve means that we know the output value. So essentially, we want to know when there's 0 gallons of gas remaining. So we have 0 equals, and then our equation, our expression, and we're m plus 17. So we're going to subtract 17, and then we divide by negative 0.04, and we end up with m equals 425 miles. Okay, so its practical meaning would be, so after driving 425 miles, 0 gallons, or you can say the tank is empty. 0 gallons of gas remain. But keeping in line with what we wrote in part D, what we wrote in part E, I'm just repeating that language, but you can definitely say after driving 425 miles, the tank is empty. So now the practical domain, remember domain comes first in the alphabet. So the practical domain would deal with the number of miles because that is our input. And so our practical domain, so the least number of miles is 0, all the way up to and including 425. Now you could argue 425 should not be included because 0 gallons means you're out of gas, but so we could make that argument. However, we're just going to go based on what we see here. And so we know that practical range is the gallons. And so the practical range is when we run out of gas with 0 gallons remaining. The variable for the number of gallons is G, and we started with 17 gallons in the tank. So now we want to use the point of intersection method. So we're going to use Desmos to calculate the 10 and the 0. So essentially the same thing that we did in part F for this second calculation, because we're solving in both cases. Remember that each of these are output values, and that's why we're using the point of intersection method, because that means we're trying to find out where those things intersect. Okay, so we're going to go to Desmos and type in the function. All right, so we have g of x equals negative 0.04x plus 17. We wanted to know when g equaled 10 was our first one. Again, I'm only showing 6 up here, so I definitely have to move my screen down. Oh, that should be y equals, not g equals. Y equals 10. And now I got to figure out where my function is at. But I do know that the practical domain and the practical range. So I'm going to go to my wrench. And I'm going to change because I know my practical domain went from 0 all the way up to 425 that's the most amount of miles I could drive. And then my number of gallons was from 0 to 17. And so even the first time I could see where this intersection was. And so I know that if I have 10 gallons remaining in the tank, or I could drive 175 miles. Now I can change this to y equals 0 if I want to, but I know 0 is my horizontal intercept, and so I can just tap on the horizontal intercept to answer the second question. So again, the first part of the question was 175. The second part is the 425, and so that's how we would verify that by looking at the using Desmos to answer that question. And again, it always indicates that we need to state what we're doing. So we would say line 1 is g of x equals negative 0.04x plus 17. And then line 2 is y equals 10. And that answer for that was 175, comma 10. And then for the other part of that, we could just say line 1. And I'm just going to put an equation here because we've already had it. And then tap on horizontal intercept. Or you could do line 2, y equals 0.